Hey, this is Brock Lemire's Embedded Systems Design. We're looking at the I2C peripheral on the MSP430, and in this video, we're going to talk about slave operation. Okay, most of the time with a MCU, the MCU acts as the I2C master, and that's just because you have so much more kind of intelligence or capability at your fingertips because you're writing a program. However, MCUs do also offer the ability to be configured as an I2C slave. And so this can be used for just communicating information back and forth with other microcontrollers, or sometimes you can have an MCU that is dedicated to something specific, like reading its own internal temperature with its own A to D, or performing some sort of data communication, maybe up a UART, or just something very specific where you want to just use it and say, look, just sit over there and do this thing, and you're an I2C slave, and I'll come grab data from you every once in a while. The MSP430 absolutely can do that. So it's got the UC mod bits, and if we set those to 1.1, it puts it into I2C mode, of course. The other settings for B0 and B1 are SPI. And then it's got the UC MST, and that if you put that to a 0, it comes up as a slave. And that is actually the default setting. When you're a slave, you don't produce a clock, so you don't have to do anything with the clock setup. So you don't select a clock source, you don't do, the pre-scaler, so you don't have to do that setup. And then the way that you dictate your own slave address is you write a value to a register called your own slave address. So it's I2C OA, so that's own address. The MSP430 actually supports up to 4 separate slave addresses. So you can actually configure this thing to look like 4 separate devices, and then you can have 4 different functionalities on the MSP430 to do various things. So it's very powerful. The registers are, you see them in the data sheet as EUSCI_BX, and then you see ICOA, own address, and then N. And it turns out that the labeling for them is A0, A1, or OA0, OA1, OA2, and OA3. And these registers kind of look like this. So you have an address down here that occupies 10 bits. It's called the I2C OAX. And it occupies 10 bits because you can have 10-bit addresses, although almost all the time you have 7. That's the default 7-bit address. And so you put that thing in there, and the first thing that you do when you set these up is you have to put the MCU into receive mode, because the first message, or the first part of the message, is going to be to come out and say, hey, is there a slave out there with this address? Okay. And so that's kind of the way that you do that. Okay. You have you have an enable bit. So if you're going to use one of these registers, you have I2C own address enable. So not only do you have to initialize the address, you have to initialize that specific address register, and then it has like this overriding enable, and it's called the general call response. And so this basically turns on and off the entire slave system. And you do this if you're kind of in a mode where you're like, I'm doing something, I don't want to have any more responses. So if the master, for example, let's say that you have one of your addresses, slave addresses, set up, and somebody sends that and you acknowledge it and you're doing something, and you don't want any of the other registers to accidentally get seen also. And so you can actually disable this. You can disable the ability for the slave addresses to acknowledge while you're doing something. And this is separate from actually turning on the entire system. This is an overriding enable, and it's only present in the A0 register, and it's the 15th bit. All the other ones have their 15th bit as a reserve. So this only exists in, it would be OA0, okay? Each of these 4 addresses have their own transmit and receive flag. And that, now if we come back and look at the flag in local enable registers, that's why we have these RX IFG0 and TX IFG0. And you come up here and you got RX IFG1, flag 1, receive flag 1, transmit flag 1, receive flag 2, transmit flag 2. That's why these all exist. These are all used for slave operation. When we're master, we only use these ones down here, but now that we know we can have 4 independent slave addresses in slave mode, that's why you have these other ones over here. Okay, so that's where all this go from. Okay. The acknowledge, when everything's enabled, if there is an address put out by the master and it matches any of the own slave addresses that you've enabled, the MSP430 will automatically send an ACK. Okay. And then whether or not you are going to, whether or not it is a read or a write, remember that comes from the master. So we actually don't control that. It is the master that's requesting that. However, whether or not it's a read or a write sets a corresponding TX or RX flag. So it's like, oh, you're going to read? I'm going to set the transmit flag so that I can, as an MSP430, transmit back. Or if it's, oh, I want to write, then that sets the RX flag and you say, okay, I'm ready to receive. So you kind of got to flip your thinking around in that you are the slave and the master is requesting from you to read or write to you. Okay, so then in order, depending on whether it's a read or a write, you're going to use the transmit and the receive buffers. That's how you're going to send information back to the master or receive information from the master. Okay, so let's think about a transmit. So let's say that the slave has requested a read message. So it sends out a start bit, sends out a slave address that matches one of our own addresses. We acknowledge, okay, and then, well, before we acknowledge, it says, I want to read. So the read comes in, we acknowledge that we have that, and that fires the transmit flag. So we as the slave are going to transmit back. And so after the transmit, or after we ACK, it will send information out using the transmit buffer. Okay, so now let's think about a receive. So the master sends out something and says, hey, start bit, slave address, and I want to transmit, and it sends a write. Then we say, yep, and we are ready for a receive. And so then we use the RX buffer in order to receive information. Okay, so it's sending information to us. Okay, cool. All right, that's basically it. It is actually pretty simple. Just like with all the peripherals, when you're in slave mode, it's a little bit simpler. You don't have to create the clock, and you are at the mercy of the master. And so what you do is you just set yourself up, and then you wait for messages to come in, and then you respond via the transmit and receive flags. Okay, so that is it. That's the entire I2C peripheral on the MSP430 FR2355. All right, so as always, remember, support my channel by subscribing, and see ya.